Hey, so hello everyone. My name is Glenn, this is Danny, and Wilson. Our product name is HASHBROWN. It's a play on fun. Alright, so how many of you guys recognize what this is? It's a show of hands if you know what it is or you don't. It's essentially like a checksum SHA-256. Originally, it's used mainly for file verification, file integrity verification. So basically, we download a file off of the internet, to ensure that the file you've downloaded is in fact intact and it's actually valid, and it's actually the same file as what the author is intended to download. But the problem is that's not enough. Like checksum does not guarantee authenticity.
Authenticity.
Yeah, authenticity is a hard word. Yeah, it doesn't guarantee authenticity. So what happens is malicious actors can do like a man-in-the-middle attack by spoofing, because oftentimes these checksums are stored in plain text files. So when a website is hacked, they can easily manipulate these the checksum, and then so we download the file they download will also be malicious as well. So that's like the real world problem. So the current checksum protocols and man-in-the-middle attack, and as we all know, the WannaCry ransom attack, and that's how Trojans and worms are infected. They're propagated throughout the networks. Right. So what is our solution? So our solution we're proposing today is simply storing a cryptographic signature of the documents on a decentralized database, and ensure the system works with any file transfer protocol, so it doesn't have to be anything on blockchain, so it can work for multiple different other file transfer protocols and file host websites. And we're going to track the change of hash on open blockchains. So for example, Ethereum smart contracts, we all know that they're infamously slow for the speed. So that's why it's going to be like periodic snapshots rather than a constant update. And the constant update itself will be done on the BlueZil network. So this is our architecture that we're envisioning. So we have BlueZil here running on a swarm of nodes, node 1, node 2, and node 3, and we're hoping to leverage the infrastructure of BlueZil and then building a layer on top of it that allows us to communicate with any of the file transfer protocols. So this is like a process flow of how ideally. So what it is essentially a user would generate a private and public key pairing, and he'll create like a cryptographic hash with the files, and then sign the hash with his private keys, and it'll store, and the information will be stored in the BlueZil database. And the user can retrieve it by simply getting the public key and decrypting the hash retrieved from the hash database, and then he'll have his own copy of the file, and then hash the home copy, and then compare it with equivalent. So now we're going to move on to a demo.
So we're going to do a demo now. So here, this is our homepage. You can go to register. Our register file. You can try inserting a file. And you can go to the list and see that after we can hash that file, and it will be inside the database. And then you can go to query and drag that file in and verify. It will show that the file is like the same as the one that was registered.
If you change the content, it wouldn't verify, basically.
Okay, we're for future plans, we would want to partner up with like third-party authentication system. We're part of GitHub to make sure, like when you push a bowl, it will be the same. And for Dropbox and Google Drive to ensure accurate data, as well as we can partner with Spotify to make sure music hasn't been modified by third-party programs. And for future plans, we're planning to create a JS library to allow users to support different cryptographic hash protocols and create extension for automatic validation of digital content when importing and exporting files.
Thanks, guys. Mike, yeah. Well, sorry, you guys have this mic too. Got some questions? You guys mind to come in and step into the light, please?
Sure.
So, am I correct in understanding this in that it takes a file name and then you can register a hash with that?
Not the file name, the file content.
Okay.
Yes.
So how does it determine? So I mean, like you had one file that was called demo.txt,
Yes.
and say someone else has a demo.txt. How do you know you're going to the right one? Like, is it based on a user account or?
Yeah, it's based on a user account, and
Okay.
that's why we have in the proposed plan. There's like a public and private key pairing. So the private key you would have like the user with the private key would sign off that document to ensure that this is.
Okay. And say you're like I gave a file to someone else, right?
Mhm.
So with my private key, or sorry, with my public key
Mhm.
and the file name, they could then verify that.
Yeah,
correct?
exactly.
Okay, gotcha.
So I want to add on that. Like, so ideally, we want to implement this in more like a Linux file system. So you have like full paths. So you can have like file with the same name within the single user account, and it will still work. So.
Yeah.
On your slide, I saw it said you could track the change of the hash.
Yeah.
Why would the hash change?
Because we're also supporting like an update of the file. So whenever, because if you're a legitimate user and an owner of the copy of the file, sometimes you want to change the file. For example, in open collaboration, so you want to update it, right? So and that the hash would update as well.
Well, fortunately, I have infinite storage, so it's just a different file. Right, so I don't need to update the specific file, I just make another file and give that file.
So that's like, well, given that you have in the storage and the scalability of Boozoo, right? So, but if you don't have, but if you work with like a limited capacity sometimes and resource, it's still.
How do you propose to manage private keys and the identities so that you know that the public key that's verifying is the person you think that it is?
That it can, well, you can pretty much do like a blockchain wallet, so the user can store the public key, like store the private key, and then we'll have like public keys on our server, our end, so you can do a relation that way.
Say two, there's two different versions of my Ethereum wallet, software version, whatever, on there, and they're different, signed by different keys. How do you decide which key is the right one and which one's a scam?
That's the public key that's in charge. So you have to give like the coordinating public keys. So that relies on the user part. So you have to give, let's say you have like 2 copies of the Ethereum wallet. So you just can't get the public keys mixed up between the 2 wallets, right? So
You have to already know which public key is the right one and which one's
Yeah,
wrong.
identity isn't part of it, I think.
Yeah, 100%.
Okay.
Yeah, I just needed clarification for the demo. So you uploaded a file,
Yep.
text file. You're not storing the file name because the file name is irrelevant.
Yeah, it's irrelevant. File name is completely irrelevant.
So then when you uploaded the next file and then you wanted to authenticate it, did it kind of go through an array of valid hashes to determine whether it's legal or not? Or how does it do that?
Sorry, can you repeat your question again?
How did, when you,
The hash of the file is the key that you use to look things up in the database?
Yeah, no, hash is the value. We're using the file as like the
Contents.
the file name, to be exact, as
so
the
file-
key.
So the file name is
Is the
relevant.
key, yes, is the key.
Okay, so,
Yeah.
right, within that user profile. Okay, so the file name is relevant.
File name is relevant.
Okay. All right.
Do you want to say something about that? Because I downloaded the file from them, but I changed the name when I saved it. No, it's
So this is actually a real world problem, but kind of has also been sort of executed by you saving the end. So this is like a real world problem. It has affected some software. I think like VLC and stuff has been affected before, but then like Linux distributions figured out one additional way to sort of distribute the software correctly. So instead of just having the file name and the SHA sum, they also additionally sign it with GPG. And that would ensure that it's much harder for you, because then when you do a verification, you do a GPG check sync. So like many, I guess you don't use Linux, but many of these Linux package managers actually keep track of signatures. Though I guess maybe your use case is more for files that are going it's more peer-to-peer as opposed to that. So yeah, just keep that in mind when you're doing that in terms of the demo from the start.
If you have a key already for every user, they might as well sign it.
Right. Anybody else? All right, thank you very much. That was excellent.